Hi, my name is Dale Maley, and in this short video we're going to talk about a very interesting project I recently completed, and it's how to repair broken masts on a model ship. And this project has quite an interesting background. A gentleman by the name of Leo Nichelis made this USS Constitution model when he was out of work during the Great Depression in the 1930s, according to family lore. He made an oak display case with glass to hold his finished ship. He died in 1943. The ship was inherited by his daughter, but she put her plants on top of the display case and watered the plants. Unfortunately, the water leaked down through the plants and ruined the oak pieces that were in the display case. So the case was removed but not replaced. The next step in this interesting story is that Leo's grandson inherited the ship. Unfortunately, his pet cat knocked the ship off of a shelf. It fell 5 feet to the ground and broke all three main masts up about 2/3 of the way up from the deck to the top. And when I Googled this on the internet, I was surprised to find at least 4 other cases where cats had knocked off finished models onto the floor and either partially damaged them or completely destroyed them. Now here's a photograph of the way I received this model for me to try to repair it. The coffee cup there is for scale, so you can see it's a pretty good sized model. And in the refrigerator in the background, the crack there between the upper freezer and the bottom door, all these masts were broke off in that general area. So that's the 3 main vertical masts. Also the 45-degree mast on the left, the tip of that was also broken off. It was a pretty sad state of affairs for such a wonderfully built model. Now a little bit about my background. I have 50 years of hobby woodworking experience. I build everything from furniture to buildings to toys, you name it. But I've got zero experience building or repairing little wood model ships. I'm also a mechanical engineer from the cornfields of Central Illinois, so I do not know a single nautical term. So as we go through this video, you'll have to excuse me if I do not call some parts by the correct nomenclature. So after studying this broken wood model for a little while, I came up with a strategy. And this is my basic strategy on this sheet. So I had to cut the strings to remove the top broken sections. There was no way to get them back in shape and glue them back in shape, so that was really not an option. So I cut the strings off the top broken section, remove that section, and then make a new mast top section. Now the old mast going down to the deck, I cut that off about a 1/2 inch below the break. Used a Dremel with a cutting wheel to carefully cut that. Then I got some aluminum tubing of the right inside diameter to make a sleeve that would connect the old lower mast to the upper new mast. Then I would epoxy that sleeve into place. Then I'd have to restring the affected strings. I did not want to disturb the strings below the break point. I wanted to preserve the gentleman's work. Plus I didn't want to have to try to figure out how to restring all the lower section too. So with respect to what materials to use on the new upper mast section, I decided to go with 1/8 inch diameter birch dowels. The old sections were about 1/8 of an inch. They're actually a little bit tapered, but I'm going to stick with the 1 diameter 1/8 inch birch dowels. There might be a better material than birch, but I don't really have any oak dowels that small, so we're going to try it with birch. Then for the horizontal pieces that actually join a couple sections of vertical mast together, I went with 1/8 inch thick hard maple, and I have a lot of experience with hard maple, and I thought it would work good for this application. So my first question then was, how do you rip 3/4 inch thick hard maple into 1/8 inch thick strips, around 1/8 of an inch? Several years ago I bought a interesting fixture for my table saw, and what it does, it allows you to rip very thin sections on your table saw, and then it lets you make those thin sections exactly the same size. Now here's a picture of the special fixture on the left hand side. It's anchored into the groove in the table saws. And basically it's got a roller then, as you can see in front of the blade, and then you move your fence up until the board is contacting the roller. You run it through the saw, and for the next cut you put the piece of wood back in there and then slide the fence up against it, pushing the wood against the roller. And the end result is every strip that you rip is exactly the same thickness. Once I cut the thin horizontal pieces out of hard maple using that special fixture on the table saw, I then took it to the drill press and very carefully drilled 2 1/8-inch diameter holes, and then I took those pieces of hard maple over to the scroll saw with the finest blade that I have, and I cut out the shape of the horizontal pieces. And then I dry assembled up the 1/8-inch dowels and the horizontal pieces as shown above, and once they're in the correct position, I applied super glue gel using a toothpick to the outside area of all the joints. Now, a handy tip that I learned the hard way over 40 years of woodworking experience: you don't want to drill holes close to an edge because you run the risk on small parts of having it split. So in this case, I started out with a little bit bigger horizontal piece, which is actually 3/4 of an inch wide from the standard 3/4 inch thick hard maple. And these pieces are less than 3/4 of an inch in there. So I've got a bigger piece to start with. Very carefully drilled the holes, 1/8-inch holes in the drill press using a very slow feed rate. And then I took it to the scroll saw and cut out the shape. What this method does, it leaves more stock around the drilled holes, so you have less chance of breaking the piece while you're drilling it. Now, when I explained this project to my favorite paint consultant at the Fairbury Ace Hardware store, he suggested that I use super glue in a gel form. And I've used super glue before, but I didn't realize it came in a gel. And the regular super glue is awful runny, so it's hard to keep it in one spot. And he suggested for what I'm doing, the gel would be much better. So I used a toothpick to apply it, and then there's 6 little containers here. They're made for one-time use only. And that means if you use one of these and you got 5 left, they stay okay. They don't get hard like a regular super glue does tube. And typically I'd use 10% of the tube, put the cap on, and within a month it'd be rock hard and no good anymore. So once the super glue had dried, I applied an oil-based stain. Normally in woodworking you brush the stain on or rub it on, and then you rub the excess off with a rag. But on birch dowels it doesn't really take stain very well at all. So in this case I brushed on with an artist brush the stain and then left it, did not wipe it off. Dried it in the oven at 120 F. Now, on the original USS Constitution ship, which is still floating in Boston Harbor, certain sections of the vertical mass are white and some are brown. So I painted the white sections with flat white latex paint, let it dry. I removed the old cross mass so I could reuse them. I tied the cross mass on the main vertical mast, and I did use special rigging thread that I bought in different sizes from Amazon. Now here's a photograph of the original top section on the top, labeled old, and my new pieces, labeled new, are shown here after they've been stained. And I'm ready to paint the white sections on the new piece and transfer the old cross mass. So you can see I got the brown color pretty close to match the original. Now when I went to transfer the cross pieces, horizontal cross pieces, over to the vertical main mass, I wondered, how do you keep that cross mass in the right position up and down? And as I disassembled the old one, I noticed that the original builder tied a string up on a higher feature. In this case there's a groove at the top. Tie that and knot it off, and then run the string down to where you want the cross mass to be. Then wrap around both the vertical and horizontal piece and tie a knot. And what that does, gravity helps you keep the cross mast at the correct height. Here's a photograph when I got done transferring my first horizontal cross mass onto the vertical one. And I don't know if you can see in this picture, but I do have the piece of string tied off at the top first, going down, and then wrapped around both the vertical and horizontal piece and knotted off. In this picture, you can still see my ends of the strings look a little bit long, and I probably should nip them off a little bit, but on the real model you can't even hardly see those short ends, and in fact you need a magnifying glass and a pair of small scissors to go in and trim these some more. When I was first starting this repair project, one of my friends, Roger Friedman, made an interesting suggestion. He said I ought to make a temporary fixture with a piece across the top above the ship that would give me a place to hang stuff and do other things. And if you stop and think about it, many modern shipyards have overhead cranes to help build the ship. So I made a temporary one out of 1x4s as shown here, and I have a piece of dowel going across the top. It turned out this was really handy. It helped me hang the new masts vertically, get them in the right place vertically, and it also helped me have something to attach to keep the new upper mast section from rotating out of position. Now here's a photograph I took the day that I glued all three new mast pieces into place. You can see my temporary fixture with the dowel going across the top. What I did to keep it in the right vertical orientation, I used a paper clip attached to the top of the new mast section, then ran rigging thread up to the dowel and taped it in place with blue masking tape. Then they wanted to rotate in the aluminum sleeve out of the into the wrong position. So the only thing I could think of was to get some pipe cleaners, attach that to the end of the horizontal mast, and then run it up and clamp it to the dowel. And it takes 4 hours for two-part epoxy to harden, so I didn't want them to move in that 4-hour window. And it turned out this method worked really well. So because it takes 4 hours for the two-part epoxy to set for the aluminum tubes, I decided to go ahead and epoxy all three masts on the same day. And it worked out okay. As you can see here, all three masts are being held in the proper position. Now here's a photograph of one of the repaired masts using my white refrigerator as a background. I don't know if you can see, but the little aluminum sleeve is down near the bottom of the picture, and I did go back and paint those brown to match the color of the ship. Now here's another photograph of all three vertical masts are now repaired. And as I said, I went back and painted the aluminum sleeves brown to match the old ship. So on the left hand side, upper left, we have a before picture of the very damaged ship with all three vertical masts broken. And on the lower right, we have the after picture where I've repaired all three of the upper masts. So on every project I do, I always have some lessons learned. And on this particular project, what I learned was you can make very small parts using normal woodworking practices. I wasn't sure I could make those new upper assemblies up there with such small pieces, but it did work out. Also, the idea of using aluminum tubing as a sleeve to connect the lower goods section of the mast and the new part on top, that worked pretty well. It let me preserve the original work the builder did below the break, and it means less restringing for me than compared to making completely new mast. And yes, I will be building a new case to protect this ship in the future. So in summary, this short video explains one way to repair broken masts on wood model ships. Hopefully this video gives you some ideas and helps you on your projects. I hope you enjoyed this video, and please subscribe. Thank you.